The overall goal of my current project is to organize my chemical storage, get rid of stuff that's no good or that I can't use, and then start playing with whatever's left. In this shot, there are 4 bottles of chemical. 2 of them are basically empty. So let's use them up in a classic demonstration. This bottle of peroxide will be the first to go. $10 milliliters. 10 milliliters? Why is this still on the shelf? Well, it's not anymore, is it? Next up is the food coloring, and that's almost gone too. Let's see if we can squeeze out a drop or two. I guess not. I'll pop off the little dispenser plug and add a small amount of distilled water to wash it out. Shake it up a little bit. That's better. Next, I'll add some dish detergent. This is pretty old too. They discontinued it a while back and I got a bunch. Unfortunately, most of it spoiled over the years. Who would have thought soap could spoil? Anyway, a quick mix, and then I'm going to add just an arbitrary amount of this 2 molar sodium iodide solution. The sodium iodide will be oxidized to iodine, and that acts as a catalyst to decompose the hydrogen peroxide. And what is this? Are you kidding me? All that water I added to the already low volume of peroxide must have diluted it too much. No self-respecting chemist would leave the classic elephant toothpaste demo with such an impotent display. I can't leave it at that. And so I won't. This time I'm using a little bit more peroxide. I had fresh food coloring and I've measured out the sodium iodide. That's much better. This next demonstration is often staged as a chemical magic trick. I don't drink alcohol, so I usually tell audiences that I'm thirsty, but whiskey's not my style. So I'm going to turn it into some water. Of course, it's not really anything to drink before or after the demonstration. But aside from that, it's really easy to do. Just cap the bottle and give it a good shake. Here's how I did it. Take the cap and apply a little bit of rubber cement. As you can tell from the brush, this is pretty well used and kind of old too. Next, sprinkle a few crystals of sodium thiosulfate onto the rubber cement and let it dry. To prepare the whiskey, just fill a bottle with some tap water. An actual whiskey bottle works best if one is available. Then just add enough iodine tincture to give it a good color. There's no fermentation, distilling, or years of aging required. It's much easier this way. Once the cap's on, shake it up. The shaking will dislodge and dissolve the sodium thiosulfate, which will then reduce the brown-colored iodine to colorless iodide. In the right bottle, or with the right story, you get a nice illusion thanks to a little chemical magic. For younger audiences, I usually call it tea for obvious reasons. Moving on. Here's a 1 liter bottle of tin 2 chloride solution. This demonstration used to be part of my regular show. I phased it out because the reaction does take a little while and I usually forgot about it by the time I was supposed to show off the product. By the way, I mixed this solution in the year 2000. These last 30 milliliters have been sitting there for probably 3 years. I did use this in a show not too long ago, but it wasn't enough to use it up. Now's the time. This is a simple single replacement reaction used to teach the activity series. Pretty much all you have to do is drop a chunk of zinc in the solution and wait. Crystals of tin do start to form right away, but they get bigger and prettier as it goes on. In the solution, tin is an ion in the +2 oxidation state. The zinc is metal in its neutral oxidation state. Because zinc is more reactive than tin, when it hits the solutions, the electrons fly from the zinc and jump over to the tin ions and reduce them to tin metal. In this demonstration, this happens essentially at the surface of the zinc. There's also some hydrochloric acid in the solution. This reacts preferentially with the zinc. If there were a larger volume of solution, the tin would be deposited on the surface while the acid ate out the zinc underneath. Eventually, the hollowed out tin crystals would float to the surface with the help of hydrogen that's generated as well. That doesn't happen in this case because the original zinc piece was far too big for this volume of solution. This angle shows the hydrogen bubbling up from inside. Tin metal does react with hydrochloric acid, but so long as there's zinc present, the tin won't react with the acid. When you get in nice and close, you can see how shiny the tin crystals are. You can also see the hydrogen trying to push it off the bottom. The similar reaction between aluminum and copper chloride that produces metallic copper produces copper that's very dull. This is a nice reaction in that the crystals have a chance to grow rather than just precipitate out of solution. Here's the final product. There's still quite a bit of zinc left in this example. When removing it from the solution, it's best to decant off the acidic solution, then rinse the metal with water a few times, decanting off the wash each time. Even though it's unfinished, it's still quite nice to look at. Next up, I've got this little vial of strontium nitrate left over from an ancient bottle that was basically empty when I got it. I have new strontium nitrate. Well, my version of new. It's already 4 years old and never been used. Anyway, this little vial is only wasting space. So I'm mixing it with a little sugar. I'd like to get rid of the sugar too, so why not? I'll mix them together as well as I can with this little spatula and then take a match to it. Sugar plus oxidizer should give a good burn, and with this being a strontium salt, we should see a nice red color. Okay, here's the match. Let me get the lights. Really? That's it? Well, that wasn't very impressive. Let me try a butane lighter instead. Well, there are hints of red. The camera isn't really picking them up too well. I'm not happy with this. Sugar and nitrate should be much more exciting than this. I'm thinking maybe they just aren't mixed up enough. I'm going to grind them together, including all the already burned bits, and hopefully the increase in surface area and the closer contact will provide a little bit more exciting of a result. Okay, straight to the butane lighter. Here we go. Well, at least this time it's able to sustain itself burning, but this isn't anywhere near the firework effect I was going for. There is some red color visible, but it's mostly yellow, and then it just goes out. I want to see how it's actually burning. It almost appears as though there's a layer of charcoal that forms and sort of prevents it from further combustion. Alright, I'm done. At least the strontium nitrate is used up now. The next video will be the last in the series of cleaning out the chemical storage, at least for now. I'll continue on the theme of using up some extra chemicals that I have no real interest in keeping. Then we can move on to the part I've been really looking forward to. I'm going to try and get the next video out before the end of the year, and then I'll introduce the next series within the first few days of 2019. Thanks a lot for watching, and I'll see you next time.